Hi, hello dear students, welcome to our channel Maths with Panindra. In this video, I am going to discuss about mathematical induction 7 marks questions. Let us have a discussion. The question here, show that 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square plus and so on up to n terms is equal to n into n plus 1 whole square into n plus 2 by 12. So first what we have to do that for the solution, let the given statement will be S of n. S of n is equal to 1 square plus 1 square plus 2 square plus and so on. So that are also I will write it. 1 square plus 2 square plus 3 square plus and so on up to n terms is there, no? So what about n terms means 1 square plus 2 square plus and so on plus n square will come is equal to RHS side what value is there, n into n plus 1 whole square into n plus 2 divided by 12. Okay. What is that nth value? 1 square plus 2 square plus and so on n square. Sum of the squares of first n term. So S of n we can write it as, once again I am writing 1 square plus 2 square plus and so on. This can be written as sigma n square now, dear students, is equal to n into n plus 1 whole square into n plus 2 divided by 12. Okay, what is sigma n square? This we know that. We already studied in the 10th class, sum of the squares of first n terms. 1 square plus 2 square plus and so on. N into n plus 1 into 2n plus 1 divided by 6. This is the value of sigma n square is equal to n into n plus 1 whole square into n plus 2 divided by 12. I hope everyone understand. After that, 3 important steps are there to prove the given statement by using mathematical induction. So, the first step, what it is, to prove the step S of n is true for n is equal to 1. So, step 1. To prove that S of n is true for n is equal to 1. This question one of our students, our subscribers requested. On behalf of that I am doing. It will help for him, and not only for him but also for the students of my channel. So to prove, how to prove S of n is true for n is equal to 1 means, this LHS you have to consider. LHS of this question, LHS. What is LHS in this? In S of n, what is nth term we wrote now? That is called LHS. N into n plus 1 into 2n plus 1 by 6. Calculate n is equal to 1, substitute in this. So 1 into 1 plus 1, 2. 2 into 1, 2, 2 plus 1, 3 by 6. So 6 by 6, which is equal to 1. Similarly, RHS you can take. What is RHS? The required, we need to prove this one. N into n plus 1 whole square into n plus 2 divided by 12, which is equal to n is equal to 1, substitute. So 1 plus 1 whole square, 2 square means 4. 1 plus 2, 3 divided by 12, that is equal to 12 by 12, which is equal to 1. Therefore, LHS is equal to RHS S of n is true for n is equal to 1. S of n is true for n is equal to 1, that is S of 1 is true. So first step completed, dear students. Now we will move to the second step. In the second step, what we have to do is, let us assume that in step 2, let us assume that S of n is true for n is equal to k. So what is the meaning of S of n is true for n is equal to k means, in the given statement S of n, wherever n is there, replace with k. That's all. So that is S of k is equal to 1 square plus 1 square plus 2 square plus and so on, k into k plus 1 into 2k plus 1 divided by 6 is equal to k into k plus 1 whole square into k plus 2 by 12. So this is a second step. Okay. In the third step, in the step 3, we have to prove the given statement S of n true for n is equal to k plus 1. We have to prove that S of n is true for n is equal to k plus 1. So first, kth term is there. To prove the given statement S of n for n is equal to k plus 1, we have to find k plus 1th term of the series. So k plus 1th term, wherever k is there in this is the kth term. You remember, this is kth term. I will rub this. So wherever k is there, k plus 1. K plus 1th term is wherever k is there, k plus 1. So k plus 1, k plus 1 plus 1, k plus 2. So 2 into k plus 1. So 2k plus 2 plus 1. So 2k plus 3 divided by 6. This term you have to add on both sides for S of k. So to prove the given statement true for n is equal to k plus 1, adding k plus 1th term for S of k on both sides. So this is S of k now. Whenever we are adding these values, k plus 1th term, it will become S of k plus 1, dear students. Keep remember. So you write it as it is, 1 square plus 1 square plus 2 square plus and so on, k into k plus 1 into 2k plus 1 by 6 plus k plus 1th term is what? K plus 1 into k plus 2 into 2k plus 3 by 6 is equal to, what is RHS value? RHS value k into k plus 1 whole square, k into k plus 1 whole square into k plus 2 divided by 12, plus we are adding k plus 1 into k plus 2 into 2k plus 3 divided by 6. I hope you understand. RHS value we have to prove in the statement is there, no? In the given statement, wherever in the RHS of given statement, wherever n is there, we have to replace with k plus 1. In this way we can prove that. Yes, I will give it, that only. So which is equal to, from these two, k plus 1, k plus 2 by 6 I am taking common. So k plus 1, k plus 2 by 6 I am taking common from both the terms. So k plus 1, k plus 2, if we take out common, the remaining is k into k plus 1 by 2. So here also k plus 1, k plus 2 by 6, if we take out, 2k plus 3 only remaining by 1. Now take LCM, k plus 1 into k plus 2 divided by 6 into 2 is the LCM. So k square plus k into k plus 1 is k square plus k, plus 2 times of 2k plus 3. So that is equal to k plus 1 into k plus 2 by 6. So by 2. So k square plus k plus 4k plus 6. So now factorization we can do, dear students. K plus 1 into k plus 2 by 6 into k square plus 5k plus 6 by 2. So k plus 1 into k plus 2 divided by 6. Here factorization, k square, 6 can be written as 2 into 3, no? So k square plus 2k plus 3k plus 6 by 2 from these two. So k plus 1 into k plus 2 by 6. So k into k plus 2 plus 3 into k plus 2 by 2. Again k plus 2 take common from these two. So k plus 1 into k plus 2 by 6 into k plus 2 into k plus 3 divided by 2. So we can write it as k plus 1, k plus 2 whole square, k plus 2 into k plus 2, dear students, into k plus 3 divided by 6 into 2, 12. So now we can verify whether in place of n k plus 1 is there or not. So k plus 1, k plus 2 can be written as k plus 1 plus 1 whole square. It is in the form of n plus 1 whole square only, dear students. N is equal to k plus 1 now. So k plus 1, n into n plus 1 whole square, n plus 2. So k plus 1 plus 2, k plus 3 can be written as by 12. So it is true for, therefore last conclusion step, it is very important, dear students. Most of those students, they won't write. S of k plus 1 is true. Otherwise S of n is true for n is equal to k plus 1. S of k plus 1 is true. After that, last conclusion step, by the principle of mathematical induction, by principle of, this is finite mathematical induction. Not compulsory to write, but if you write, it is well and good. By principle of finite mathematical induction, S of n is true for all n belongs to capital N. Hence proved. For this statement only 1 mark out of 7, you remember, dear students. Okay. We will do that another question in the another video. Thank you. One question I will make in one video, easy to understand. So once again, just I will scroll down. Dear students, this is LQ. We may expect a question. Just go through what are the steps. Thank you.